Fine, if you can hear me clearly. Okay, so I want to welcome everyone to a new week. And of course, I want to welcome you to my lecture today. Of course, today, before I get started, I'm going to make some announcements. I actually extended the deadline of submission of assignment 7 by 24 hours because of the responses the feedbacks and responses I was getting from the students. And I'm going to use an opportunity to shed more light on the assignment 7, as the assignment 7 is very, very straightforward. And I'm also going to give tips on assignment 8. Okay, so I'm going to start with assignment 8. We only have one question, one problem in assignment 8, except that we have, 6 sub questions. And I want to give clarification about what assignment 8 is asking about. The data set you're going to load for assignment 8 is what I'm showing now. It's a data on MEEC. And this is an online data. The moment you copy that into R, you do attach MEEC, of course, you're going to have access to that particular data. The variables in the data actually include diet, cow, weight, and protein. Now, when you look at the first problem, plot the data showing how protein changes with time for the 3 diets. Before you can actually produce something like this, you need to load a lattice. So this question A now is only asking about you generating a plot. The plot that is going to look like this, where you have protein against weight, and you have for 3 different diets. I'm going to go into the second problem in assignment 8. Fit random intercept model to the data. Use LRT. The LRT is likelihood ratio test, which we call the ANOVA test, nested ANOVA test we've been using last week, to determine your best random intercept model. What do I mean by that? You're actually going to fit 2 models, and you're going to compare them using nested ANOVA. What are the 2 models? The first one, you're actually going to have diet plus weight, where you are testing main effects. And the cow being subject is the one that is nested on intercept. That is why we have a random intercept here. The second model is still going to look like this, except that instead of a plus, there's going to be a multiplication sign, which means you are fitting 2 random intercept model. One without interaction, the second one with interaction. So if you take a look at what you've done last week, okay, the one for without interaction, you actually have, because protein is a response, okay, on diet plus weight plus 1 vertical bar cow. Cow is the subject. This is without interaction. Okay, the one with interaction, I'm going to have protein, diet, multiply, weight plus 1 vertical bar cow. Either this and this, I'm still talking about random intercepts. Except that in one module, except that in one without interaction, with interaction. If you take a look at that B, fit random intercept modus. That's a plural. 2, this guy and this guy. I believe those of you online can see what I'm writing on the board, right? Can somebody confirm? If you're online, confirm if you're seeing what I'm writing on the board. For those of you online. Okay, let me see. Okay, thank you for confirming that. Now, since you now have 2 modules, then you're going to do ANOVA into the first comma, the second one. Of course, the simpler one is going to be this guy. The complicated one will be this. Then you choose using the p-value. We did that last week. That was what I was expecting in B. In C, fit random intercept and random slope to the data. Instead of having this, okay, instead of having the only difference between the random intercept and the random slope, if I want to change this to slope now, I'm going to write slope. Then another variable is going to be here, 1, which is going to be 1 plus week. Of course, you know, the week is like a repeated, right? As the same way subject is repeated. Okay, so here, I'm also going to have 1 plus week giving cow. What has happened here? I'm doing random intercept, random slope. How many modules do I have? 2. For main effects, for the interaction. Now, if you take a look at that very C part, that is what he's trying to tell you. Okay? Now, in the D part, test whether the correlation between the random intercept and random slope is statistically significant. I mean, it's statistically different from 0. What do I mean by that? This is a situation where the better, you know, you're going to choose the best here, right? I want you to listen now. You're going to choose the best between this and this. Whichever one that is the best, you're actually going to create another 2 form of model. One that we have 0. You remember last week, one that I put plus 0, right? That will be plus 0 is uncorrelated. The one without 0 will be correlated. Then you conduct ANOVA, nested ANOVA test. In the non-hypothesis, what you're going to see in the non-hypothesis will be uncorrelated. Alternative will be correlated. That is what he asks you to test whether correlation between that is statistically significantly, you know, is statistically different from 0. If I want to test that, it means I'm comparing 2 model, both of them, they are random intercept, random slope. One correlated, the other one uncorrelated. When I reject H0, what am I trying to say? Don't forget, H0 is saying uncorrelated. Alternative is saying correlated. Then it means the correlation is significant. That's what it means. Test whether the correlation between random intercept and random slope is statistically different from 0. That is what you are testing. Testing between uncorrelated with the correlated. When you reject HO for the uncorrelated, you are accepting the correlated, then you are trying to tell the world the correlation is significant. Does that make sense? Now, the last question the question E now said, you choose the best module among the random intercept. You also choose the best module in D, right? Now, between the two modules that you choose, the best in the random intercept, the best in the random intercept and slope, you compare the two because we want to know the best of the best. That is what E is talking about. He said, test your best modules. Best become two. Best from the random intercept, best from random intercept and slope. You use ANOVA nested test again. Which one are you going to put in the non-hypothesis? The one you're going to put in the non-hypothesis will be the best in the random intercept. The one you're going to put in the alternative is going to be the best in the random intercept and slope. You now choose the best. That is what E is talking about. But do you know F? F is a bonus. Extra credit, 3 points. You know why? I have never thought that I just introduced you to error structure is what I want to discuss today. If you can grab what I want to discuss today, then you will have a bonus of 3 points. That is for F. You may decide not to go for F. Does that make sense? It's an extra credit point for you. Now, I receive another response.